This question, we have a big fraction. We're going to put this root under all these. Let me show you. So here, I'll bring it down. I want to take the derivative. So, so we have 3x squared plus 8x plus 7 over square root of x. Now, you might think we'll just do the root of this one, this one, this one, this one. No, 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 no. You can't do that. Functions added are fine, but they're all really divided. And so when you have dividing, you can't do that. Now you could do the big fancy quotient rule, which means you do the whole top, then the bottom, then but you know what's way easier than that? Instead, rewrite it. Well, it's no derivative yet. Just rewrite it, meaning what? Just make it three separate fractions. It'll be a lot. I know that might not seem easier, but trust me, it will be. So it's going to be 3x squared, 8x, 7, and they're each going under the root of x, like that. And in fact, actually, you know what? Let's save some time. That is, let's clean these up. Those are x to the half power, aren't they? Let's just make them that way. It'll speed us up. Okay. So see, when you write it that way, then you can just say, okay. So now, again, I'm still doing cleanup. I have not taken any derivatives yet because you might say, okay, so now you can just do the derivative of the top and the bottom. No, that's illegal. When you have two functions divided, we have a whole big special rule called the quotient rule, but I like to avoid the quotient rule when I can. So instead of that, I can just subtract the powers. Remember, you can just take the top power minus the bottom. So this will be 3x to the 2 minus a half. And this will be 8. And this is what, a 1 power up here. 1 minus a half. And what happens here? This guy just jumps up to the top. I want everybody, but when he does, he becomes a negative power. So this is still cleanup, no derivatives yet. Now, what is 2 take away a half? Well, if you're not sure, I'll do it over here real quick. 2 take away a half. How do you subtract fractions? You got to put this over 1, and then you multiply the top and the bottom by 2. So it becomes 4 over 2 minus 1 over 2 is e over 2. Right? You got to get common denominators. That made these denominators the same. You can subtract them. So then that is x to the 3 halves plus 8x. 1 minus a half, that's easier. That's a half, right? Okay, notice I've not taken the derivative yet. All of this has been cleanup. Why did I do all that cleanup? Because now they're nice. Now they're just in the numerator with powers. There's no dividing. So now take the derivative of all three parts. So there's the prime. See how this was f? These were all f, just the original function f. But now it's f prime. Now we're taking the derivative. What happens? The power rule comes on down, huh? 3 times 3. How's we do? Subtract 1 from the power. 3 halves minus 1. And then this half comes on down. Plus 8 times a half x to the minus 1 there. That's half. Minus half comes down. 7 times the half. X, subtract 1 from the power. Minus a half minus 1. See that? I did the derivative rule. And so what does that leave you? How do you deal with this? When a whole number is acting with a fraction, it goes to the top. 3 times 3. 9 halves. Now what happens here? 3 halves minus 1. That's 3 halves minus 2 halves. 1 is 2 halves. So that's minus 5 halves. Half of 8 is 4. Right here, did you see why that became minus? Because that minus half multiplied the plus 7, so it's minus 7 halves. That 7 goes to the top because it's 7 over 1. Any whole numbers over 1 goes to the top, right? Okay, they know all these fraction rules. And then what is this? Minus a half minus 1. That's, we're going up here, minus a half minus 2 halves. 1 is 2 halves. That's minus 3 halves. And there we basically go. that how they put it? They made those powers into fractions. Oh, wait a minute. Did I mess up there? Oh, I did right here. This is a mess up. It was 3 halves minus 2 halves, which is 1 half. What in the world was I doing? Sorry about that. There we go. I looked at the answer and saw that I was wrong. Do we have it right now? 9 halves x to the 1 half plus 4 x to the minus zero point 0.5. Yeah, you can make those decimals if you prefer. Minus 7 halves x to the minus 1.5. Yeah. So I'll say, or this is fine. You type this in, it'll take it. Or you could just divide all these fractions. 9 halves is 4.5. This is a 0.5. You want to make everything decimals or some of the things decimals? That's fine. Minus, you can make that a decimal. Make that a decimal. Minus, you can make this a decimal if you prefer. X to the minus 1.5. Either way, it'll take it this way or that way. It's all good. Just don't mess up like I did. 3 halves minus 1, 3 halves minus 2 halves is 1 half, not negative, or whatever crazy thing I said before. And so there we go. So what did I do? I did a bunch of cleanup. You see that? Because why? Why did I didn't want to do the quotient rule. When you have x's divided, you either clean it up or you have to do the quotient rule. You can't just say, oh, I'll just do this and this and this and this one separately. No, 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 no. It's fine for the adding. Sure, those are fine, but not, they're divided by the denominator. So no, it wrecks the whole thing. You'd have to do the quotient rule. The quotient rule is a kind of a big pain. I don't know. I think it's harder. So I think it's easier instead to clean up when you can, to just clean it up. And when can you? Well, because I didn't have any adding or subtracting in the denominator, I could just put that one denominator, that x to the half, right? That x to the half, and I just put it in the denominator, denominator, denominator. And then I could just divide the three fractions, subtracting the powers, and get it into a nice clean form where we didn't have any dividing of fractions anymore, any dividing of x's anymore. No more fractions. And then I could just do the power rule on all three of them, do a little bit of cleanup, and we're done. So there we go. Do that when you can.